Okay, welcome everyone again. I'm happy to introduce our next speaker of the session, Jeff Brown. Jeff is serving as a managing director at the Stanford's Sustainability Accelerator. Jeff has immense experience in commercializing sustainable products, and he carries a wealth of industry experience. Jeff was founded and CEO of Novi. He was a vice president of Emirates, developing new products from synthetic biology. He founded Itumi, a company commercializing eco-friendly lubricants, and has many years of experience leading petroleum research programs. Jeff has worked in solar industry as Director of Engineering at the Zero Code. Further, Jeff served as a Director of Engineering at the Angstrom System, a developer of ALD, atomic layer deposition systems technology for semiconductor industry. He has worked at Applied Materials and Motorola as an engineer developing new products. With this wealth of experiences, Jeff holds several patents and publications on his name. Jeff holds an MS in mechanical engineering from Stanford University. With this introduction, I welcome Jeff on stage to share his expertise titled How Universities Can Drive GHG-R Impact with Speed and Scale. Welcome, Jeff.
Thank you very much, Dalian. It's really a pleasure to be here with you all today and talk about the work we're doing at Stanford and hopefully motivate everybody here to partner and work together to make significant change here in climate. So the title of my talk, as said, is how at universities can we drive greenhouse gas removal impact with speed and scale? This is something that's been identified as critical over a decade ago. And we've yet to make the progress that we need to maintain our targets set at the Paris Accord. So I'm going to first talk a little bit about what we do here at Stanford in the Sustainability Accelerator, give you a framing for how we work, how we go after these problems and the breadth of our research. And then I'll get quite specific, talk about the greenhouse gas removal flagship, the work we're doing, and then how do we see the scale and impact challenges, and how can we make a difference at universities? And then lastly, how do we focus on success? What can we do together within this community globally in order to bring the change and impact that we need? So the School of Sustainability is new at the Doerr School. We were founded just over 2 years ago. It was, as you can see in the name, it was a gift by John Doerr, established the school. And John Doerr had been a venture capitalist for many years at Kleiner Perkins in Silicon Valley and fought on the front lines of bringing new technologies and ideas into climate space. But that model was failing to create impact. So Stanford and John worked together with the other leaders to say, how can we design a school that can bring impact into climate that we haven't been able to achieve so far? And you can see the mission here, accelerate the translation of research into scalable technologies and policies to address urgent global sustainability challenges. So how do we do that? The school is designed differently than any other schools here at Stanford. You can think of us as 3 legs of a stool, where each leg is a significant pillar. The first pillar is what you would typically see with students and education and faculty and degree programs. The second pillar is our institutes here at Stanford. We have the Precourt Energy Institute, the Woods Institute for the Environment, and we're starting a new institute around sustainability. And where I sit is the unique piece, which is the accelerator. So the accelerator's job is to bring impact. And so here at the accelerator, we translate that research, not just in this school, but throughout the entire campus. And the impact, the success of the school is going to be measured by how well we do translating these ideas, technologies, and policies into the outside world. So how have we started this? We started here on the far left, working with faculty, working with students to define what are the interest areas. Where do we think we can make a significant impact in climate? at Stanford. And then we form these and develop solutions around them. And our goal is to be inclusive of the entire campus. We don't limit ourselves to just technology projects. We work across finance, economic, policy, education, anything that we think is going to drive impact. And then we partner strategically within each project space with external partners across the entire value chain. Um, and that can be on the customer side, it can be on the supply chain side, and anything you need to think about scale. And the mindset we work is we take the very big goal of scale and we work backwards from the start. So how does that manifest itself? Um, we're organized here under areas that we call flagship destinations, of which we have 6 of them. A flagship destination is one of those areas that I talked about earlier with a measurable target. So here we have greenhouse gas removal, where our target is gigaton scale removal, climate adaptation, affecting the lives of 1 billion people by 2035, electrification of the grid. How do we get to zero greenhouse gases from the grid by 2050? Industry, you can see. So where we have a measurable, aggressive target that we know when we hit it, we're making the impact we need. And then we structure the project space and all of our work underneath that. And we ask all teams, write your proposal, think about what you're doing, and explain how you're going to reach that scale and what you need to make that impact. In addition to the 6 flagship areas, we have 2 cross-cutting platforms. Planetary intelligence. This supports all flagships using AI, sensing technologies, data to provide actionable insights across any of those targets, and similarly, biological solutions for sustainability. Here, any one of those flagships, we can have biological systems to create significant impact and enhance the solution. So overall, we have 8 targets. Today, greenhouse gas removal is fully up and running and funded. The other 6, or excuse me, the other 5 flagships and the 2 cross-cutting platforms will be up and running in spring of 2025. So the RFPs are now open, and we're going through the grant process of those. So let's now talk specifically about greenhouse gas removal. This slide is about carbon dioxide removal. I'm going to focus much of my talk around that because that is the most developed piece of greenhouse gas removal. So if we think about it at a top level, the main greenhouse gases we're concerned about are carbon dioxide, methane, and nitrous oxide. With carbon dioxide being the most mature, where we have significant work going in the field. I like this chart. This is from the stateofcdr.org. It's a very good report if you want to get up to speed on the state of the industry. But what we have here on the left is all the different methods that we can use in CDR. What type of core technology are we using to capture that CO2? Is it biological? Is it geologic? How is it stored? And then are they conventional, or some people say nature-based or synthetic? And then readiness levels, mitigation, and a very important topic is the time scale. Are we talking decades, centuries, or millennia? And there's one column not missing here that's critical, which is the cost. And the cost is, because we have not scaled, it is the unknown. But if you can imagine that bar being here on the right that we're all working on, we're working across this difficult space to say, hey, look, we need all of these solutions. Can't be one winner, but what's the appropriate allocation of effort, of dollars, of R&D, in order to get this to scale to make an impact on carbon removal. So where are we today with this? So if you take a look at the latest projections and publications, we're not meeting our reduction targets at the rate that we need, unfortunately. So the more delayed our reduction in emissions is, it puts more pressure on the need for removals in order to hit our targets. So these charts are from CDR FYI, which is a great site for tracking real time what's going on in the CDR market. And here you see carbon removal purchases. And often, we hear a lot about offsets in the market versus removals. Here, we're going to talk specifically about removals. We're not going to get into that offset space, which is typically more linked to that reduction side. But you can see here the growth from 2020 to 2023, and that looks phenomenal. But if you look at the projections where we need to go, we're still 2 orders of magnitude off here and the volume of purchases. So this is 4.5 million metric tons of CO2 removals purchases executed, and we need to get up well over 1 billion. And in fact, the current estimates are about 10 billion metric tons annually are where we're going to need to go. And now if we look at the difference between purchases and delivery is the amount of carbon actually removed. And so here you can see how small this number is, 125,000 metric tons. And this is dominated today by one of the methods I showed here, biochar. You can see that here. Biochar is where you take bio waste and through a process of pyrolysis, you turn it into a char that is extremely durable and long lasting, and you can deploy that or use that as a product. But that's a mature technology that's being deployed. But you see the difference in scale just in these 2 numbers. So we have what we call an advanced market developing, where people are buying purchases on a forward basis to help scale and finance these technologies. But we've got a big gap, not just in the amount of purchases we need, but then also the amount of delivery that we're achieving on that. So we need to drastically accelerate this. The picture gets even more difficult when you look at the number of suppliers out there. So if you think about across all of those CDR technologies, and you think about the scale of this problem, we're going to need a tremendous amount of suppliers. But here, you see, if you look at it on a sale basis, we have 115 suppliers have made a sale in 2023, and only 50 have made a delivery. So we're talking about an industry that we need to get to the scale of, there's only about 4 industries of this scale in the world today. So you can think about cement, you can think about the automotive industry, you can think about the water industry and the food and ag. And you can just in your mind mentally picture the scale, the amount of suppliers and the amount of people delivering there, and how big CDR has to get and where we need to go. And then on the buyer side, we have a lot of very little buyers, but when you get to the buyers making significant purchases, again, we get to a very small number, so 14. This is dominated. Microsoft is by far the largest buyer in the world today, but you have many of those tech companies that you're familiar with, Stripe, Google, Amazon, and others, and a few set of financial institutions here buying. So we need to really help this market get moving. And as you know, a lot of people have pledges to achieve carbon neutrality, net zero. In order to get there, everybody's going to have to get in the game here. And also interesting to point out here, the average price for these purchases in 2023 was $444 per ton. That's a blended average across all of those CDR technologies. So I'm going to talk a little bit later here why that number is so important. So let's take a look at what we've done here at Stanford. So within our greenhouse gas removal flagship, every project that we fund has the opportunity to make gigaton scale impact, right? That's our flagship destination target. And we funded now 21 projects. We've got 16 on the screen here. And when you just think about the projects individually, it's hard to understand where they are and define a strategy. But when we organize these projects and we think about these as a strong cohort, and how do we work together um, in order to move the entire field forward, this is where the strategy really starts to come into view. So if you think about all those different types of CDR we talked about, you can break them up into three major categories: atmospheric removals, terrestrial based, and oceanic. And so across all of these major areas, we fund technology projects. So direct air capture, here we're greenhouse gas removal. So we also have methane removal and nitrous oxide removal projects. In the terrestrial space, everything from agroforestry, um, looking at distressed lands, looking at reforestation here using um, fungi to accelerate growth and soil carbon sequestration capability. Biochar, here's a very innovative project using worms to help enhance weathering and soil health for soil sequestration. Mineralization, enhance weathering, and then in the ocean side, biomass through seaweed and a couple of ocean alkalinity projects. So what's really important here is um, we have this field covered. It gives us phenomenal view into the state of the market, the state of the technologies, the challenges. And then in order to progress to an actual market, we need what's known in this field as MRV. MRV is measurement, recording, and verification. That's the transactional layer of verifying that you actually remove the amount of CO2 that you said you would, and you can transact that. So sell that as a credit, count that on your balance sheet as a removal, what have you. So we've got a number of projects on this layer to execute MRV. Here, a very novel project to do on a chip level with a laser detection of all your critical greenhouse gases at the ppb level. In the terrestrial space, risk and insurance frameworks in order to finance agroforestry, forestry, reforestation projects, low-cost soil CO2 sensor technology, broad techno-economic analysis for the entire field for economic and finance strategies, biochar, MRV, enhanced weathering MRV, and then in the oceanic space. So I go through all this to explain it's a difficult field, right? And you need to gain a very deep understanding. This set of projects covers 40 plus faculty and over 60 students. So when you bring that mass, that might of brain power and capability together, is when you really start to innovate. And what we're doing now is we're going to build an additional layer on top of this, which is our policy layer. And so we're kicking off a policy fellowship program, and you can imagine that stacking right on top of this. And if you were thinking about how do we get to scale and how do we implement, you're moving vertically out of this page. You need to have a technology that works. You need to have a market in order to transact and finance, and then you need to have policy in place to enable that to scale. So with this in place, we start building the ecosystem and the knowledge. And I think this has been the most surprising and the most exciting piece of building out the accelerator. Um, we work very hard to get these teams together as much as we can. It's really important to have the oceans team understand what's happening in atmospheric and vice versa. The challenges are different, but they're quite similar in terms of scale, finance, measurement, and of course policy. And we see a lot of very common themes that are critical in this space for success, and we can work on those. And very importantly, a mutual appreciation gets established. We need everything to succeed here about the scale we're going. And one of the things that happens in these fields, especially when you start getting into the startup community, is, one type of solution points a finger at the other and says, we're better than that. That's not very good. We can't act like that. We can't work like that here because we do need everything. And whether you're a nature-based process or a geological synthetic project, they will all play a critical role here. This rapid exchange of tools and ideas, um, I think we need to think really hard about the students and what we do with them. We're building climate and sustainable entrepreneurs for tomorrow. And that's a very different type of entrepreneur than we're used to. And the reason for that is the market and the geopolitics and the rapid pace of change here. It's not like the software market, the AI market, or the medical devices, or the drug market. And we really need to exchange these ideas and the tools for success, and we amplify that success. And then really important, tolerance of novelties. Oftentimes the winners are the non-obvious ones or the crazy ideas. And we need to fund those projects as well, because these challenges are so broad. And when you fund at this scale and you can allow this many projects to participate, it allows you to tolerate and let the novelties come in and inspire across that entire ecosystem. So we've done a good job of building this here at Stanford so far. We've built a educational track for all of our teams. We focus not just on technology, but policy. They're all introduced to that, on economics and finance, on social issues, and we engage communities to think about how these will be implemented and rolled out. And to truly create impact, you need to engage the world, and that's our next step. This is what we're going to really be pushing hard in 2025. We think that there's a very interesting role for universities and institutions here to play together, to cooperate. Um, and what do I mean by that? We're at a place where we have a lot of questions around CDR, around how do we measure, um, how do we count, how do we finance, what technology will work, and universities can play a very critical role here by working together to demonstrate what is working, what is acceptable, and what can get us here. We're not in pursuit of perfection. We're in pursuit of good enough, and defining good enough is actually quite hard to do. Um, and this is where we can work and we can help our governments out. And we need to help our governments globally out. The other interesting thing when you think about the layer is, because there is no existing market, and you saw that on the prior slides, where is the workforce to do this in the private industry? It doesn't exist. And so we have to think about our faculty, our students, what we have here. We are that workforce that we need to progress this forward. We need to help the governments. The governments can't do this on their own. And this is a very different strategy. And like I said, again, this challenge forces us to think very differently here. NGOs, of course, are a critical layer. How we engage them, set standards and scale, engage communities. Um, Corporations ultimately will be the ones that scale this, that transact and buy these. But we need to bring corporations along. We need them to participate. They're the ones that are running the scalable solutions today. So we need to participate with them about how we think about that scale, um, how they're actually going to start playing a role. What can we do as universities to help corporations participate more? Instead of pointing the finger at them and saying, you caused this, you need to fix this. We need to really be a lot more strategic and thoughtful about how we bring that together. And then ultimately governments. This is going to come down to governments. But again, this is very difficult. And we need to help governments. We need to allow them to get good policy uh, in place. Um, and so I see a question here from Julia. I think I can address that before we move on really quickly. Um,
Jeff, you're able
so
to see the
here,
you are able to see the question. Should I read it for you?
I have it.
All right, thank you. Yeah, please go on.
So Julia's asking about different carbon removal solutions in forest management, and as well as issues around agriculture techniques for CDR and the durability. So let's talk about those here. You see on this first one, you've got the afforestation, reforestation, and forest management. So this is, I would say, our most powerful CDR methodology we have today. Why? Because it works. And actually, the cost on a dollar per ton basis is below $100 a ton, and we can scale it. Um, why do I think this area is so important? We can't think about CDR uh, in its own little box. We have the entire environment, and we have sustainability, and we have communities, and we need to come up with solutions that allow the whole planet um, to heal and get better. And this is what forestry does in general. It helps biodiversity. It helps the water. It helps with thermal management. We know all of these things, and most importantly, communities around these forests can improve their economic situation if these forests are grown and managed either for food, for lumber, for economics that help that community grow. So there's a lot in this bucket. You also mentioned the soil here. We have that kind of in the middle between peatlands and coastal. Same thing around what you think about farmers improving, lowering fertilizer, improving soil, and methods we use there for crop techniques. So all of these are not just on this list, but I believe are going to be an absolutely critical piece of this because, again, it's not just CDR, it's the overall environment that we need to think about. We need to think about human health and society. Um, and yeah, on the durability side, it's a great question too. Um, and you can see in this last column, we have the time scale. We need to think about this as a layered approach. In investing, you have the time value of money. You can think about it here. We have the time value of our CO2 problem. So areas where we can get moving quickly, like in agriculture, like in forestry management, we need to do those things. Okay, it's only going to be potentially decades and a century, but this game is going to be won or lost in the next 20 to 30 years. So we have to think very strategically about how we layer these solutions together. Ultimately, we want to be as durable as possible, but you can't dismiss the shorter term ones if they're available today. And certainly when you think about that cost equation. Um, One of the most interesting things I think about this is you think typically when you have a market and you have the lowest cost supply, and it's available, that's going to win. Um, what's happening in this market is we're trending towards the very high cost of supply, which is something like a DAC, direct air capture, because it's very easy to account for. It has, the millennial scale storage capability, but the reality is it's not ready today. It doesn't provide the other sustainable biodiverse benefits either. And this is why we need to think about it all together. It's very complex. It's not a simple topic to just say one or the other, which is why we look at this in our project teams across all of that. And we did just get another question around how's it pay. I'll talk about that a little bit more when I get to some of the needs in the market. So thank you all for those questions. So with that, and I wanted to address that one again. We need all solution space, right? It's our duty at this layer that we play as universities and institutions to prove that, to embrace that. And I'm very excited about some of the future work that's going to define how we layer these together economically and financially, and what it means much broader to our communities and our economy and biodiversity beyond solely CDR. And as we move forward, those things are going to increase in value. And that's what we're going to get into with maybe that next question. So what's unique about GHG-R and innovation? When we think about it here, especially with students at the universities, it's the why. You know, it's this unified purpose with urgency. This is not the typical school. This is not the typical problem that we work on here. This is a global issue that affects literally every living being on this earth. And I'm very impressed and excited by what I see by the students. So here at Stanford, sustainability courses um, are the #1 requested course, I believe, by incoming freshmen. I think we have 33% of incoming students want to take a course in sustainability. We have to think about what that means and how we work within that. And when we put that together with the scale, that means we actually need all the students on campus. We need the social scientists, we need the computer scientists, we need the typical engineering. And that creates a great spot for innovation. And it's innovation within the university setting in order to make that impact. And so I want you all to think about, how you work, how you think. A typical model for faculty and students is, publishing and moving forward in that manner. There's a different way to do that in this space. We still want to publish. We need to get our thought and leadership out there, but that is not the ultimate reward. The ultimate reward here is getting out there and making that impact. But um, you know, what is the other unique thing here? We have no market. I cannot stress enough how difficult this is. We need to create the supply, we need to create the demand, and we need to create policy. This is not a typical situation of innovation. It's not like going after cancer, where you have all the patients there and you've got a drug community who's got a market to supply it. This is something on a scale that we've never seen, that we've never had to tackle. And so this is why, again, we need to be quite innovative across that space. If we don't have supply, if we don't have demand, if we don't have policy, if we're missing any one of these three, it will not work. And so we need all of the new ideas and strategies to tackle this. So let's talk about supply side innovation. This is, if you think about our map that I showed earlier, we have the bulk of our projects working on supply side technology. The first one, we're going to need much lower cost on a dollar per ton basis. So if you recall in that prior slide about the state of the market, I said that the average cost was $444 per metric ton. The if you look at what the latest discussions are, it's around 10 gigatons per year. If you model that at $100 per metric ton, that's $1 trillion per year for CDR. That's a lot of money. It's very difficult to see how you're going to be able to take that much money out of the global economic system to do this work. This is why we need to innovate much more. We had that question on nature-based solutions. A lot of nature-based solutions can be much cheaper than this, but we need to push technology much, much further and more aggressively. And this is why I say here at Stanford and what we're doing is you've got to think with scale in mind. If you're thinking at scale of these numbers, you're not going to work on a technology that you think tops out at $200 a ton. It's not worth your time. You need to push harder about what you're working on and thinking about. The next one is MRV, measurement, record, and verify. For any of you all in this space, this is very difficult. You think about how do you measure in the forest? How do you measure enhanced weathering, the CO2, when you deploy it in a field? The oceans are even harder. What's that mass of seaweed? That ocean alkalinity enhancement, that conversion into calcium carbonate. This is very hard, and it cannot cost a lot of money. Ultimately, we're going to have to evolve here to model-based with very low rate actual measurements in order to anchor these models. And why do I say that? If you get back to these scale industries that we talk about, how much money do you think big oil uses to QC their fuel and distillate cuts? How much money does Ford spend to verify a part in the car? We know, we have examples of what gigaton markets look like. We're not going to break those economics. So if MRV isn't a low single digit % of cost for your CDR method, it's ultimately going to break when you reach scale. This MRV layer around the modeling, this is exactly where universities are experts. This is where we need to work together much better and innovate. And we often we don't take enough data. We need to actually take more data in order to expand our scope and allow us to develop better models. And again, that's what we can do. This is a lot of the work that we're funding, but it would be a lot more effective working together across that. And I touched on this earlier. Biodiversity, co-benefits, unintended consequences. There's a lot here that we need to look at. When you think about who's executing these projects on the ground today, they're focused on getting their trees planted, getting their biochar spread, getting their rocks and enhanced weathering, crushed in on the soil. They're trying to execute. They don't have the capacity right now to look at all of the other things. That's again where we need to partner, and we need to work together. And I said it a lot earlier. We will need all available technologies. I cannot understate this. There is not going to be any one solution. If you think about this as a globe, some countries are going to be really good at a certain type. We need to go in the world where we have the most favorable conditions. That can be the environment, that can be the energy supply, that can be the ocean, that can be the forestry, that can just be communities and governments. We need to think extremely global in nature for deployment and go for the lowest cost and the most beneficial area. And then the last one, business models. I think it's becoming increasingly clear if your only business model is to simply transact CO2 and you expect the world to put $1 trillion per year in to get there, that's probably not going to happen. I would like to think it could happen, but I think we're preparing our teams, we're preparing our thinking to say, we've got to come up with a better way. And this is actually the most exciting thing I see going on right now is business model innovation. And what do I mean by that? This is a lot around the co-benefits and the biodiversity benefits. These these are monetizable streams that reduces this $100 per metric ton cost. So we talked about that in forestry, the co-benefits that you bring around the water quality, soil. We look at a lot of uh, forestry projects that take place hand in hand with agriculture to help with the water challenges, to help with the thermal challenges and soil erosion challenges. When you think about something like biochar, you think about the fertilizer benefit, the growth, same thing with enhanced weathering. We're seeing now as the teams are pushing and thinking about it, it's really coming down to how do you monetize, how do you bring benefit, and you think about the creation of a business model where, look, we're going to bring value to these communities. We're going to bring value to the overall economic system. And oh, by the way, we're going to also remove all of this CO2 while we do this. So this is actually really exciting part of the field right now to see this next level of innovation starting to happen. Okay, let's talk a little bit about demand side innovation. Most simply, we need to lower the risk to participate. If you think about a major corporation and a CEO sitting in the boardroom, why is that CEO going to propose using profits to remove carbon when it does nothing to his core business? And the time scale of the career trajectory, we're talking about decades here. And we need to position this better around lowering these risks. That includes MRV. That includes, when you're transparent about your data. How do we make sure people feel safe to participate in this market? Um, when you think about how most of the people invest in the world, we need to think about how do you craft portfolios? How do you blend risk across technologies? How do you create this transactional layer to give people confidence and execute? And we're seeing a lot of this develop, but again, I sit here at the university level, and Stanford is not participating in this carbon removal market today. So if I ask, well, if Stanford sees it as too risky, how would we get a corporation to do it? We here can lean into the learning, the education, the need to move this forward on that risk. A corporation can't do that. And so I think we have to think really hard here again about how do we begin participating in this layer as universities. We're doing it to, number one, force our teams, our students to actually take place in this market, get out of the lab and get into this market and start executing. But we're also doing it to lower the risk for everybody and ultimately getting the corporations in that we need. Um, we talked about cost a lot. It's hard to get started in something when you cannot see an end game to cost. So if I have a carbon neutrality or carbon negative goal for my organization, and I do the math now, and it's, a large percentage of the economics of my business, it's very hard to incent that person to start. So there's a lot of very novel things here around in setting business adjacent technologies, and all of this talk about business model innovation to creating that value. And these are going to be um, some very important things here. Um, and I mentioned it again, these value propositions beyond greenhouse gas removal, and and we put all that together with new economic models and financial tools. I want to push here. If you think about the time scale of this, it's very trying, it's very difficult to finance. You're going to put a lot of money in projects that take a lot of years to pay back. And so we need different models, we need different tools to structure across that. And yeah, uh, Dialon, I see your note. I'll finish up here really quick.
Thanks, Jeff. Yeah, sure.
Okay, so let me talk about policy side, really important. The number one thing we can do to help policy is get data. We're not arming our governments, our politicians, our community leaders with the data they need to make decisions. And I actually think that this is where we can play an incredible role in helping this move forward. We do not have transparent data in this industry. We don't have a schema for data that we can work across the different types of technologies to evaluate them and how they work together. Um, and so I think you're going to see this as becoming a really increasingly important piece of this. And then there's a lot of opportunities around policy, but if we don't bring those people the data and we don't bring value to the constituency of those politicians, it's going to be very hard. I think we're going to start to see some federal carbon dioxide removal procurements to help the markets along. We have compliance markets today and fuels. We could see compliance around CDR coming. Um, Ultimately, it is going to be the policy that brings transparency and credibility and the frameworks to do it. In Europe, they're talking a lot around the border carbon adjustment. Um, and then I think actually as we develop these future business models, um, we're going to come up with a lot more targeted economic and business sector um, policy side innovation. But I just want to stress how important the universities are in getting this data, putting the thought out there, and linking the communities and everybody together to innovate across that as well. So. Um, Thank you all. I want to leave time. I know we've got a lot of questions in the chat box.
Jeff, this is Ravinder. I'll handle this Q&A session. While okay, well, you have already answered one question. There is this second question I can see from KJS Public, and it's about policy finance question. It says, who pays for GHG removal when the costs are astronomical and it's a fundamentally international issue? Any quick thoughts there, Jeff?
Yeah, it's a great question. I think we have to get the cost to a point where it's not astronomical. This is the disconnect we have today. We've got to get the costs, we've got to get the benefits, we've got to innovate on business models where it is something that we can transact on internationally and understand what everybody brings to the table, the global south, the north. And ultimately we need to think about this as a business, and a business has to self-sustain. And we will always have government support and assistance here. I don't want to minimize that, but we need to get the cost in the realm where we allow our governments to participate to do that.
I see. Well, there's another question from Charlie, and that is, what is the most disruptive technology that you have been looking at? Or what is your favorite technology?
Oh, that's a great question. I don't have a favorite. I'm agnostic. I have to be. I'll be honest. I do have a very soft spot for the nature-based solutions. I do think we do not give enough credit to the value they bring broadly to the environment, to communities, and again, that opportunity for wealth creation that brings costs down. Um, I think the synthetic solutions are going to be the workhorse long term, but we need a lot more technical breakthroughs. We need to get the energy demands much further down. And when you think about the scale of CapEx and how much has to get built, we need a lot more innovation. And I think what's very interesting about looking at all these technologies we work with today in the teams, I'll postulate that we probably don't know what it is today. I think those inventors of tomorrow is our job to create them today, and we need to get them in this complex soup of policy and social issues and entrepreneurialism. And it's going to be this new batch of students who are going to come up with these great new disruptive technologies for the future.
Well, thanks, Jeff. A remark for participants: if you have any follow-up question related to the questions that have been answered already, please write in the chat box. We'll try to take all questions in the next 10 minutes. But if not, at least Jeff will have all these questions so that he can follow up later, or you can follow up later with him. Thanks. Jeff, there is another question from Sagar, and that question is, what are the challenges and opportunities in standardizing MRV methodologies for supply side emissions? And how can universities and research institutions overcome them?
Thank you for that. I think the number one thing is we need to get in the game. We need to get in the data game. The problem that's happening today is the data is not transparent in the industry, and it's understandable why. Because you've got projects that make their data available to their buyer, but they're very worried about the risk around that data and, whether, the external world will call that, false or not happening. And the only way for us to help is we need to get involved in projects, and we need to get involved with getting data and taking data, and then we can enable our global access to scientists at universities to work on that data. And ultimately, I think it's going to be the model development and AI tools around this that is going to allow this MRV to significantly drop in cost and become standardized. But we can't start that work if we don't get in the game and get transparent data available to everyone.
I see. Next question I see is from Dayalan, and the question is, what are the major challenges among scaling, storage, and monitoring?
So I'll start on the monitoring. I think that's data. I think that one is very difficult today, but I think we'll overcome that one first.
Mhm.
I think ultimately it's the scaling. When you really think about how big this has to be, and you think about the amount of dollars, you think about the amount of land, you think about the amount of steel if you're building something, it is quite staggering. And
Mhm.
you think about the cost of what that means. I think that's the one that's going to be the everlasting challenge here is we're never going to stop working that scaling piece in my mind. I think the storage actually does get worked out as well. We know ways to store. It's the cost of getting all of that to that scale piece.
Okay, well, next question is from Sagar again, and this is about consumer behavior. And the Sagar is asking, consumers may need to think a few times before adopting sustainable behaviors and products, as the initial cost may be higher. How can we effectively engage and convince consumers on the demand side? And what policy incentives can governments implement to encourage demand side adoption?
Great question. I don't know what to do on this consumer side. Um, the more that climate affects everyone in the world, I think the issue is it's not homogeneous. Some people experience drought. Some people have too much rain and water, right? And they have flooding. And some parts of the world are rich, and I'm sitting here in California, and just across our state, it's so varying based on where you live, whether you're impacted by the oceans, whether you're impacted by the snow. So I try not to think too much around that consumer side. I think you're absolutely right. We need to figure out how to reach them better. Um, my personal struggle here is just how heterogeneous that is and how hard that is going to be to cover that. But I hope that as people really see the effect of this impacting them every day, they change their view. And then, as you say in your note, we can better effectively engage, and the government can help. But I don't have anything there, unfortunately, for you.
But Jeff, a follow-up question to Sagar's question. We in academia, you mentioned about students very actively participating in sustainability related courses. Is there anything that can be done at that level so that maybe in next 5 to 10 years, you see a change, you see more awareness, etc. And the incentives from governments are maybe not required.
I mean, that would be incredible. So the awareness, yes, I think that's a great point. We see it in our new student body, right? We know how aware we are, and how big of an issue is. I think we've just failed to translate that uh, over the past few decades here. Um, and I think the question is do people start to feel it enough that they get connected to make those changes? And I don't know, but when I also talk about here at Stanford how we're agnostic to solution space. We're happy to fund a documentary, for example, if it is about education and communicating. We have to try everything we can here to go after that. We need to pull all of these social knobs. Um, and yeah, I think we'll see that. I know I'll just put a plug. There's a new documentary out, Legion 44. It's the first CDR documentary that's been out. And I think, yeah, I think we're going to see more of this direct engagement, and people become more aware of the issue.
I see. Well, thanks, Jeff. There is another question from KJS Public, but I'm also conscious of the time. We have 2 minutes left for the next talk to start. So I would like to stop at this point, and perhaps if you could take up this question, or maybe KGS Public, if you could directly write to Jeff as a follow-up, perhaps that may be more effective. I would also like to remind everyone, all participants, that on-demand recordings of the online forum, they will be available to all at later time. So with this, I would like to thank Jeff one more time for his once again for his time, and look forward to the next interesting talk. Thank you very much.